Hello and welcome to Chapter 6. And in this chapter we're going to talk about interest rates. Interest rates are what is the cost of money in a business sense. Money isn't free, and if we borrow money to fund some kind of a project or operations, that is the interest rate we pay. And we're going to look at what determines those rates and how they change over time and what we mean by a yield curve. So what are four factors that affect the level of interest rates? Number one is production opportunities. Number two, time preferences for consumption. Number three, risk. And number four, expected inflation. The last two are really important when we're looking at rates. Generally, the riskier something, the higher the rates are going to be because you have to be compensated for that risk. And as inflation goes up, as we've seen in the real world recently, interest rates are going up as well. So let's take a look here at the difference between what we mean nominal and real rates. And this is something that you may have encountered already in economics. The letter R represents any nominal rate, and R with an asterisk represents the risk-free rate of interest. Usually this is represented by the T-bill rate or the government security rate, and it typically ranges from 1 to 4% a year. This is the risk-free rate of interest. We consider government securities to be risk-free because the government has never defaulted on them. And RRF represents the rate of interest on Treasury or government securities. So the risk-free rate is generally the government security rate. Actual interest rates that are charged to businesses and consumers are always going to be higher because they have some sort of risk component. What determines interest rates? So interest rates have the following determinants. You start off with your risk-free rate of interest, then add an inflation premium, a default risk premium, a liquidity premium, and a maturity risk premium. And we're going to go into what all of these are as we go through the chapter. Inflation premium is pretty obvious. Default risk premium it pertains to how likely a company is to default or the borrower is to default. Liquidity premium has to do with how liquid is this debt security, meaning how easy is it to resell. And maturity risk premium, does it get riskier over time? That's maturity risk. So if we look here for types of debt, what premiums are added? So everything has an inflation premium. Maturity risk premium, only long-term securities. Default risk premium, only the corporate ones. Treasuries do not have a default risk premium because to date the government has never defaulted. And finally, liquidity premium, only once again the corporate securities. We consider government securities such as treasuries very highly liquid because they're really easy to resell. There are always buyers for treasury securities. Whereas corporate bonds, if you own a bond in some exotic corporation or a corporation that a lot of borrowers may not be familiar with, they may be very hard to find someone to resell to. If we look here, the yield curve shows us the change in rates over time. So it's the relationship between interest rates and yields and maturities. And it's a graph of the term structure. In March of 2020, that's what the Treasury or government security yield curve looked like, going from the short term for less than a year, rising up to 30-year long government securities. So in this case, as you can see, the rate was increasing as time went up. As time went up, we draw an arrow here, interest rates going up as well. So as time goes up, interest rates were climbing as well. So how do we construct the yield curve? So first off, we find the average expected inflation rate over years 1 to n. So we would find the average expected inflation rate. And then we would calculate it in. So assume inflation is expected to be 5% next year, 6% the following, and then 8%. So our inflation premium for a 1-year security is just 5%. A 10-year would be just the weighted average, 5 plus 6, and then 8% times 8 of those years, 7.5, 20 years, 7.75, so on and so forth. We're just doing an average. And you must earn these inflation premiums to break even versus inflation. If you made 7.75% on your money for a 20-year investment, you actually wouldn't be earning anything here in a real sense. You're just keeping pace with inflation. Even though you're making money on paper, your money is losing value due to inflation. So your actual purchasing power hasn't changed. So to break even, you must earn at least the inflation premium. To make a profit, you have to earn something more than that. So even though it might look great on paper, you made 7% in 20 years, if the inflation was 7.75%, you actually did not make money in a real sense. So keep that in mind anytime you're looking at rates. Inflation is a major part of how they're determined and what is baked into those rates. So when we're constructing the yield curve, up next is what is known as maturity risk. So we want to find the appropriate maturity risk premium. In this case, we're going to use the following equation. 0.1% times t minus 1. So as time goes up, the maturity risk premium is going to go up as well. In this case, 1 year would be 0, 10 years 0.9%, 20 years 1.9%. So since this equation is linear, the maturity risk premium is increasing as the time to maturity increases, as it should be. So the longer term a security, the larger the maturity risk premium will factor in. Really short-term securities do not have a maturity risk premium. So once we add our risk-free rate before inflation, and then add in our inflation premium and our maturity risk premium, we'll find our appropriate nominal rates. So our base rate is 3%, not taking into account inflation. And then once we add inflation and maturity risk, 1 year 8%, 10 years 11.4%, 20 years 12.65%. So as you can see, rates are going up as time goes up as well. If we want to look at a hypothetical yield curve, this would be an upward sloping curve, and most yield curves are upward sloping. As inflation runs, as time increases, rates are going to go up. So the larger the yield to maturity, so longer duration, the interest rates are going to be higher as well, due to that notion of inflation and maturity risk. They don't always have to be upward sloping, but they usually are. We'll go into some examples when they're not. If you are in very bad economic times, for instance, deflation, where money is becoming worth more, you have major slowdowns in the economy, you could actually get a inverse yield curve where longer duration bonds actually have a lower interest rate than short-term ones. But the upward sloping yield curve is the most common one you'll encounter. What's the relationship between the Treasury 1 and 1 for company bonds, corporate bonds? Corporate yield curves are higher than that of Treasury securities, though not necessarily parallel, and the spread between corporate and Treasury yield curves widens as the corporate bond rating decreases. As we get into the next few chapters, we're going to dedicate an entire chapter specifically to bonds and look at how they're rated. The riskier a company, the worse the rating on a bond. Eventually they can achieve what's known as junk bond status, and they pay higher and higher interest rates as a consequence. The downside is they become riskier and riskier. So even though they pay really high rates, they are very risky. Since corporate yields include a default risk premium and a liquidity premium, the corporate bond yield spread can be calculated as the following. The corporate bond yield minus the Treasury bond yield, or default risk premium plus liquidity premium. Because remember, Treasuries do not have a default risk premium or a liquidity premium. So if we look here, the brown line is the Treasury line, and then we have AAA, AA rated bonds in green and BBB in blue. The A credit rating bonds are better than the B credit rating bonds. As a consequence, the B credit rating bonds pay a higher rate of interest. The worse your credit rating, the more interest you're going to have to pay. Think of bond ratings similar to personal credit scores. If someone has a bad credit score and want to buy a new car, they're going to pay a higher interest rate on that car loan than someone with a very good credit score. Corporate bonds are the same thing. The riskier the company is perceived to be, the higher they will have to pay in interest rates on money they borrow. The pure expectations theory contends that the shape of the yield curve depends on investors' expectations about future interest rates. If rates are expected to increase, long-term rates will be higher than short-term and vice versa. So you can get an upward sloping curve, a downward sloping curve, or even a bowed curve depending on where in time, and it all depends on what people expect rates to be in the future. We don't have a crystal ball. We don't actually know what rates are going to be in the future, so we have to make predictions using the available information. So assumptions of pure expectations. Number one, it assumes that the maturity risk premium for Treasury securities is 0. Long-term rates are an average of current and future short-term rates. And if the pure expectations theory is correct, you can use the yield curve to back out expected future interest rates. And we'll take a look at that right here. So if we look here, we have a bond going from 1 to 5 years, and the yield is increasing at 1 year from 6 to 5 years, 6.5. If this holds, what do we expect the rate to be on 1-year securities 1 year from now, 3-year securities 2 years from now? So how do we do the 1-year forward rate? Well, our 1-year rate was going to be, 1 year forward would be 6.2, so 1.062 squared. And that is going to equal 1.06 or 6% times 1 plus x, or the rate we're interested in here. This is the actual formula you're going to use, and we would get just over 6.4%. If we used an arithmetic average, so if we did that, if we use an arithmetic average, remember a year after it's 6, it's 6.2. 6.0 plus x divided by 2 is equal to 6.2. You would get 6.4. So if you use the arithmetic average, it's going to be very close as well. So that's how you can use the yield curve to determine rates in the future. Now, the 3-year one, 2 years from now, we're going to do the same thing. So in this case, 1.065 to the 5th power, or 5 years total, is equal to 1.062 squared times 1 plus x to the 3rd. And you'll get for this one 6.7005. That is your actual answer. So this would show the 3-year securities would yield just over 6.7% 2 years from now. So 2 years from now, they're going to yield more 3-year securities than they are today. What are some conclusions about pure expectations? Some would argue that MRP does not equal 0, so the pure expectation theory is incorrect. So if the risk premium doesn't equal 0, you would argue this theory isn't perfect. And some evidence supports that lenders prefer shorter-term securities and view longer-term ones as riskier. Obviously, the longer term of something, the more uncertainty, therefore it's riskier. So investors do demand some sort of a premium to hold long-term securities, and therefore maturity risk premium would be greater than 0. So keep that in mind. And finally, what are some factors that influence interest rates? Policy of the Federal Reserve, so you see them on the news all the time. The Fed raises and lowers rates. They're not directly raising and lowering rates that affect us. The Federal Reserve influences rates that affect banks, what banks can borrow money at, but if banks pay more, then they're going to pass that on and raise our rates. So policy of the Fed, budget deficits and surpluses of the federal government can affect interest rates. international factors, so how good is the global economy doing, what are rates in other countries, and finally levels of business activity. Remember, interest is the cost for money. So if we think of supply and demand, if the economy is doing really well, if there's a lot of demand for money, companies wanting money to invest into things and fund projects, it's going to raise the interest rates just due to demand. In bad economic times, recessions, interest rates generally fall quite a bit because there's a lot less business activity. So business activity is another big one which determines rates. So rates, once again, are the cost for money. And this chapter pertains to all of the things that move them and affect them and make them up. And that's going to take us to the end of chapter 6.